I'll let you know about that. Our objective for today, I can identify polyhedral and compute the volume of three-dimensional figures. Read together, 1, 2, 3. I can identify polyhedral and compute the volume of three-dimensional figures. Copy that. Now, today we're going to finish up our lessons with something in geometry that we call solids. Solids. They're called solids because they're figures in 3 dimensions. So they make a solid figure. But instead of saying solid figures, we just call them what? Solids. Within those solids, today we're focusing on something that we call polyhedral. Polyhedral. So on your fair model, I want you to write polyhedral. And today you're going to look at what we call polyhedral and what is not polyhedral. Okay? Now, sometime back, for those of you that follow, some of you watch The Big Bang Theory, they did an episode where they were focusing a lot on polyhedra, which is this. So hopefully, this will ring a bell. Everybody done with the objective? Yeah? Yes. All right, here we go. Polyhedral. What are they? Polyhedral are 3-dimensional figures whose faces are all polygons. Polyhedral are 3-dimensional figures whose faces are all polygons. Polyhedral are 3-dimensional figures whose faces are all polygons. Polyhedral are 3-dimensional figures whose faces are all polygons. Polyhedral are 3-dimensional figures whose faces are all polygons. Now, polyhedral are split into 2 different types of polyhedral. Examples, we have prisms and we have pyramids. Don't copy that yet. I'm going to show you how to do it because some of us are artistically challenged, right? So I'm going to show you how to sketch these. But the 2 types of polyhedral that we're going to be looking at are what? Prisms and pyramids. Prisms and pyramids. All right, once again, what is polyhedral? 3-dimensional figures whose faces are all polygons. All right, I'm going to focus right now on prisms. So, writing utensils down, look up to the screen. Here we go. Prisms. What's so particular about prisms? Well, that they have 2 parallel congruent bases. So let's look at that terminology. Do we know what parallel means? Yeah. That they're the same distance away from each other and they never intersect. Congruent, do we know what that means? Yes, that they measure the same. They're the same measurements. And they are bases. So that means it's no longer 1 base on the figure. This one should have 2 bases. The rest of them, they're no longer called bases. They're called faces. Now check this out. Let me show you what that looks like. Let's see. Let me zoom in a little bit more. Okay, so look at this one right here. All right. So I'm going to show you how to sketch this one so like that we can identify each part of this prism. So I want you to go to the bottom part of your example box and I want you to do the following. Ready? Here we go. I want you to place a point right there. Another one right there. We're in the example box, yes, all the way to the bottom left. Okay, I'm going to go slow because some of us struggle with these. Ready? Check this out. From this point, imagine that we're sketching points on the coordinate plane and I go 1 up, 1 to the right, and I plot a point. You able to see what I did? Okay, go to the other point that we sketched first and do the same thing. 1 up, 1 to the right, and plot the other point. Now, each of those points are called one is called a vertex, but all of them are called vertices. What are they called? Vertices. All right, so check this out. So to sketch the rest, everything that's in the front is solid. So I want to sketch a solid segment from here to here, nice and straight like mine. Next, another solid one from here to here. However, who notices that the other ones, it's kind of like if they're in the background. Is that correct? So to mimic the effect, the 3D effect that they're in the background, we're going to do dotted segments. So we do this. kind of give it the effect that it's way in the back and it's transparent. How's that? Pretty good? All right, so check this out. Next, look at this point. Everybody there? I want you to go up about a thumb size up and place a point somewhere over here. Everybody there? Okay. Next, you're going to go to the right and place another one that kind of like is aligned to this one over here. All right. Now from here, check this out. We're going to do the opposite of what we did over here. We're going to go one down and one to the left. Go to this point right here. We go one down and one to the left. Now these four, since they're all on top and we can see all of them, all these we're going to be connecting them with solid segments. So we go from here to here, from here to here, from here to here, from here to here. So what we just sketched, these are two bases. Are they identical? Yes, that's why they are bases. Now, since they're the same distance from one another, that's why they are parallel. Are we there so far? Okay. Now, once I connect, look up, these vertices to these vertices, they're going to create everything around that are called faces. So watch. From here, I sketch straight down like here. Do that. Go to this one, straight down. This last one over here, straight down. And the one that's inside of the figure is going to be a dotted line to show that it's in the back of the figure. And we just created a three-dimensional prism. How's it look? Pretty good? Yeah? Yeah. You're like, let's go from the corner. Yeah, sideways, okay. All right. So once again, here goes the parts of this prism. We have 1, 2, and these are my bases. These are my bases. What are all the corners called, everyone? Vertices, okay? And everything else that forms the whole figure are called bases. And the lines on the edge. Yes. All the segments that connect the vertices are known as edges. Are we there so far? Now check this out. When we have a prism has a first name. And the first name is given according to the figure of the base. So check this out. This prism has a base that's the same here and here. What does that look like? Let's say it's a square. So this would be a squared prism. What would it be? Squared prism, because the first name is the name of the basis. Are we there? All right. So now that we're done with the easy one, let's crank it up a notch. Let's go to the right of that, and we're going to do another one. Ready? Here we go. I'm going to make it as easy as possible. Let's do this. Start at the bottom. We're going to place a point here, another one to the right, go up, and another one to the left of that, and it looks like a square. Who sees the square here? Do you guys see it? Okay, so first do that square. Don't connect anything, just put the 4 points. Is everybody there? All right, so now watch. I'm going to start at the bottom again with the first point. I'm going to go halfway up and to the left and place another vertex there. I'm going to go to the other 2 points on the right, go halfway between these two, and another point to the right. Now we have how many vertices? 6. However, how many can we see from the front? 1, 2, 3, 4. So those 4, we're going to connect the edges, and they're going to be solid. This one to this one, this one to this one, and this one to this one. The other 2 are in the back. Is that correct? So the edges should be what? Dotted. So you go dotted from here to here, from here to here, and from here to here. All right? So now, check this out. Look up. Start from this one. Go up. We're going to place 1, 2, 3, 4. Again, we're going to start with a square. And then halfway between these two to the left, place another vertex. Halfway between these two, put another one to the right. And these, since we can see from the top, all of them are going to be solid edges. Okay? From here to here, from here to here, from here to here, from here to here, from here to here. So before I continue, who knows, think about it first, who knows the name of this figure? Don't say it out loud. It's a six-sided figure. Six-sided figure. Talk about it here. Don't know what is the name of that figure. What is the name of a six-sided figure, Bree? A hexagon. That is correct. So therefore, if this is a prism, its first name, it's not hexagon prism, it's a hexagonal. Hexagonal prism. Hexagonal prism, because the bases are that figure. All right? Yes?
So does that mean advanced species will make this?
The what?
So does that mean advanced species will make a hexagonal prism?
Actually, not advanced bees. All bees makes hexagonal prisms because that's where they put the larvae or the babies, and that's where they grow. By the way, you guys know that? Yeah. The bees grow in these chambers that look like this. Yeah, but shorter. Yeah. All right. So let's connect this vertex to this one. This one to this one. This one to this one. This one to this one. And then the two in the back, before we start drawing the number, they're dotted from here to here. There it is. Okay? And once again, we barely finished prisms, right? So what's so particular about prisms? That they both had what? Two bases. They both had what? Two bases. And these are known as prisms. They have two bases, and they're parallel to one another. All right. Are we there so far?
Yes.
To the right of that, we're going to pyramids. We're still on the example box. Let me show you how it looks. Does everybody see this? Some of you are like, Mr. Q, mine doesn't fit anymore. Then draw it underneath that, outside of the prayer model. That's mine. So I want you to write pyramids. Can you zoom in? Pyramid. What's so particular about pyramids? They have one base, and the rest of them are faces. How many bases? One. So, before we continue, look at the prisms and look at the pyramids. Talk to your neighbor, let them know what's the difference between one to the other. Go. All right, so, what's the difference from one to the other, Marissa? Prisms and pyramids. Prisms, two bases. Pyramids, only one base. Fairly simple. But the rest, they all have sides. They all have sides that are called faces, edges, and vertices, right? All right. So let's sketch some pyramids. You guys ready? All right, here we go. Somebody said no. Wow.
Wow, nice.
All right, here we go. I'm going to start at the far right. First thing I'm going to sketch the base, which is a square, but it's a little bit slanted, so go like this. One vertice or one vertex here, another one here, another one here, and another one here. It's a little bit slanted. You guys see it, that it's a little bit slanted? All right. So from here to here, it's going to be solid. From here to here, solid. From here to here is also solid because it's still on the side we can see it.
It's a smiling alien.
Thank you. So who notices that the other two, this one and this one, since they're in the background, they're dotted. So if we go dot it from here to here and dot it from here to here. Are we there? Next, look up, look up, look up, look up. Try to figure where the center of this square is. It's about right here. Is that correct? So once you figure out the center, I want you to go about an inch above that and place 1 point. And I want you to connect that vertex to the other 4 vertices. Do that right now. Connect that vertex to the other vertices. This one to this one. Whoa. Yeah. Something like that, yeah? And make a bigger vertex. All right. Vertex. All right. So look up. What kind of base does this one have? A square. So this one is a squared pyramid. A squared pyramid. Why? Because the base is a square. So, see if you can do this pyramid by yourself. This should be a piece of cake now. Start with a base, draw your vertex above, and connect the rest. I'll give you some time. Go. So, I'm going to start at the base. I draw a triangle. 1, 2, 3. You should have connected this vertex to this, dotted in the background. So that's a triangle, yes? Then I said, go to the center of your figure and go about 1-ish inch above that. Draw your vertex and connect that one to the other vertices. So from here to here, from here to here, and from here to here. Hands if you got something like that? Okay, good. All right, once again, what kind of base does this one look like? A triangle, yes? So what would be the name of this one? Tell your neighbor, please. A triangular pyramid. Triangular pyramid, all right? Any questions with polyhedra? They are prisms and pyramids. Prisms and pyramids. Why? Because they have all 3-dimensional figures with the sides that are faces. Now let me show you non-examples. Ready? Non-examples. Cylinder and cone. Now look at these. And look at these. Look at these. And look at these. Talk it over to your neighbor, let them know why these are not polyhedra. Not polyhedra. All right. Who said that they do not have faces? That is correct. This that wraps it all the way around, and this that wraps it all the way around. We just call it surface, but it's not a face. Everybody with me? Now let me show you how to sketch these non-examples. Ready? For those of us that are artistically challenged. Ready? I'm going to do this one as easy as possible. Start at the bottom. We're going to draw an egg. Draw an egg. There it is. Okay. Go about an inch above and see if you can draw the same egg above that. Similar, yeah. Then you connect one side of the egg to the other egg, and the other side of the egg to the other egg, and there's your cylinder. Yes. Thank you. Yeah. All right. So that was a cylinder. Let me go to the pyramid. To the pyramid, you start with the base. Again, draw an egg or an oval, but we're mimicking that we're seeing a circle slanted, yes? Then look at the center of that egg, go about an inch above, draw a vertex. What's that? Oh. They do have this one on Jack in the Box. Remember, it's a little hat of Jack in the Box? Jack in the Box had a little hat like that, right? There you go. And now we have a cone. Anyways, all right. So those are cylinder and cone. So.
Does that mean that there is an example and a non-example?
Polyhedra. What are polyhedra? Hashtag what? Tell your neighbor, please. Hashtag. Write it down. Write it down. Let's see. Hey, Leanne. Hashtag what? Faces. Hashtag faces. So for those of you that are playing ball next year, basketball, when they try and go and block you and you like drain a basketball, a basket in front of them, and all of them, you're going to be like, prisms. Prisms. Because they have, it's all in their faces. That would be funny though, right? You're in the middle of a game against Central and all of a sudden, prisms! What were they saying? They were like, what? That's right. Yes, Julian, go.
Hashtag 3D movies.
3D movies, all right. Hashtag what, Charlie? Polygons. Polygons. Hashtag what, Fatima? Prisms. Be nice. And so on and so forth, yeah? All right. So, some of the definitions that we, or the terms that we used, a face is the flat surface on the 3D figure. An edge is where two faces meet. A vertex of the polyhedra is the point where all three edges meet. And of course, the face that is used to name the polyhedron is called a base. All right? So let me see. I helped you with the non-examples and the examples on how to sketch those. Now we're moving on to an example. See if you can sketch this by yourself. Ready? Here we go. So if you want to turn the page over and write example 1. All right, here we go. Write this down. Example 1. It says identify the bases and faces of the figure and then name the figure. All right. So to sketch this one, here's a hint. Always start with a base. Find the vertices of the base, put those first, connect them, and draw the vertex or the vertices, the ones above, and connect those, and then your edges. I'll give you some time. Ready, go. All right, here we go. You should have done this. One vertex here, 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 and here. Solid edge here, solid edge here, solid edge here, dot it, and dot it. From there, look at the center. Then you drew a point somewhere above it, but this one has it to the side, so then you go above and to the right. And then you connect this one to the other vertices. Yes? So, What does the base look like on this one? Pentagon. So this one, the first name is a pentagonal. Pentagonal. Now, is this a prism? No, because this one only has one base, so this is a pentagonal pyramid. Hands if you got that. All right? We got this, yes? All right, let's go to the next one. Example 2. Example 2. Look up. Focus. Example 2. Don't write the verbiage since we already have the instructions. But let me zoom into the figure. Draw that one, please. Hurry up. See if you can do it a little bit faster now. Start with the base, the vertices of the base. Connect them. Get your edges. Go to the center. Go above. Draw your vertex. And draw your vertex. Let's see. Draw your vertex. Okay. All right. Tell your neighbor the name of this figure, please. Triangular pyramid. That is correct. All right. Let me move on. Look up. Don't copy this one. Look up. Look up, please. Don't copy this one. Look up, look up, look up, look up. Does everybody see that? Here's one base, and in the background we have the other base. You guys see that? What kind of base is this? Hexagon. Is this a... So the name of this one is a what? Hexagonal prism. That is correct. Hexagonal prism. Hexagonal prism. All right. So we're done with that. Let's kick it up a notch. Ready? Last but not least, once you start getting more into solids, you're going to give you something like this. Don't copy this. Don't copy this. These are composite solids. Look up. Composite solids are made up of 2 or more polyhedra. Look at this one. This one I can break it apart and it looks something like this. Yes. Who noticed that this is a squared prism? Yes. And this is a squared pyramid. Yes. And both of them make a composite figure. Does that make sense? Yes. And we could do the same thing with the other solids such as a cone and a cylinder. If we put them together, then we get something like this. Yes? All right. Where I want to get to, though, and so on and so forth. What I want to get to is this formula. Copy this one, please. V equals capital B times H. V equals capital B times H. Yeah, we just need to fix that one. Okay, thank you. All right. Now, sometime back, focus on this one. Sometime back, I give you guys the home play to go and research perimeter, area, and volume of 4 figures. A circle, a square, rectangle, and a triangle. Now, volumes, pay attention to this part. Volumes all go back to this formula. The only thing, they use different formulas for the letter B. What does this formula mean? It says volume equals base times height. But this is not a regular base. This is a capital B, which means area of the base of the 3D figure. Does that make sense? So the volume is equal to the area of the base times its height. Example Q. I'm going to draw a cylinder. There it is. Not perfect. I'm just trying to get you guys there. So check this out. What does the base look like? A circle. So how do you find the area of a circle? Pi times the radius squared. So hold on before we go. Check this out. That's for the base, right? So if they give us, for this figure, for the cylinder, they give us a radius of 10 and the height a 15, and this is in feet and feet. Thank you, guys. On your way out, can you take the trash cans back there, please? So check this out. To find the volume, what do I write? Base times height, but this is area of the base. So instead of this, what do I write? Pi times r squared times height. So now let's plug in numbers. What is pi? 3.14 times, what is r? 10 squared times 15, and once you compute all that, at the end it's going to be in feet cubed because we multiply 1, 2, 3 numbers.
Yes.
All right, your home play, guys, pay attention. I want you to research at least one of each of the ones that we did today on the Ferrier model. What were they? One prism, one pyramid, one cylinder, and one cone. I want you to find me the volume of those, of all 4 of those, okay? Also, tomorrow, be here early because there's going to be plenty of people here, so if you want to get a good seat, we start at 8 for our last Saturday Academy. Have a good one, guys. Enjoy our home play. See you guys tomorrow. Bye.